What is coronal mass ejections? Coronal mass ejections, CMEs, are powerful eruptions of plasma and magnetic field from the Sun's corona into space. The corona is the outermost layer of the Sun's atmosphere, and CMEs are one of the most energetic and dramatic solar events. During a CME, a large amount of magnetized plasma, consisting of charged particles such as electrons and protons, is expelled from the Sun's corona. This ejection is often triggered by sudden changes in the Sun's magnetic field, such as the release of magnetic energy stored in twisted magnetic loops. CMEs can release an enormous amount of energy, with speeds ranging from a few hundred to several thousand kilometers per second. They can contain billions of tons of plasma and extend tens of millions of kilometers into space. When a CME is directed towards Earth, it can interact with our planet's magnetic field and cause various space weather phenomena. The effects of CMEs on Earth include geomagnetic storms. CMEs can disturb Earth's magnetic field, causing fluctuations and disturbances known as geomagnetic storms. These storms can impact power grids, disrupt radio communications, and cause auroras, northern and southern lights, in regions closer to the poles. Radiation hazards. CMEs can emit high-energy particles, including protons and electrons, which can pose a radiation hazard to astronauts in space and can affect satellites and other spacecraft. Disruption of satellite and communication systems. The intense energy and magnetic fields associated with CMEs can interfere with satellite operations and disrupt radio communications and navigation systems. To monitor and study CMEs, scientists use spacecraft such as the Solar and Heliospheric Observatory, SOHO, and the Solar Dynamics Observatory, SDO, which provide valuable observations of the Sun and its activity. Understanding CMEs is essential for space weather forecasting and mitigating their potential impacts on Earth and space-based technologies. Coronal mass ejections, CMEs, are large-scale eruptions of plasma and magnetic fields from the outer atmosphere of the Sun, known as the corona. These ejections release massive amounts of charged particles into space, traveling at high speeds. CMEs are typically associated with solar flares, which are sudden and intense releases of energy in the Sun's atmosphere. During a solar flare, magnetic energy is rapidly released, causing a burst of radiation across the electromagnetic spectrum, including X-rays and ultraviolet light. In some cases, the intense magnetic disturbances associated with solar flares can trigger a CME. When a CME occurs, a huge bubble of plasma and magnetic fields is ejected into space. This bubble can contain billions of tons of material and can reach speeds of several million kilometers per hour. As the CME moves away from the Sun, it can expand and interact with the solar wind, a stream of charged particles constantly blowing outward from the Sun, creating complex interactions and disturbances in the space environment. If a CME is directed towards Earth and reaches our planet, it can have several effects. The interaction of the CME's magnetic field with Earth's magnetic field can cause geomagnetic storms, which can lead to the disruption of satellite communications, power grid fluctuations, and enhanced auroras, northern and southern lights. In extreme cases, particularly powerful CMEs can pose a risk to sensitive technological systems and infrastructure on Earth. Scientists and space agencies continuously monitor the Sun to detect and track CMEs, aiming to predict their impacts on Earth and mitigate any potential adverse effects. Space weather forecasting and early warning systems help provide alerts and prepare for the potential impacts of CMEs and other solar phenomena. Thank you all of you. Subscribe the channel for more updates.